Alright, so this is the third exercise in the Using Macros course. This is going to use some of the stuff that we've just talked about in terms of using macros to communicate with another program, in this case Excel. So let's look at the exercise itself. So the idea here is you have an Excel spreadsheet that contains data from a compressor test. The compressor has a displacement rate of 26 CFM, and it's a R161 compressor, and the measurements that you've taken include the inlet temperature and pressure, the exit temperature and pressure, the mass flow rate, and then also the power. And you want to take that data that is in a spreadsheet and using ease reduce it. So basically do some calculations on the data to compute the performance, so the isentropic efficiency, the volumetric efficiency, and then with an energy balance also what the heat transfer rate is from the compressor. So here's what the spreadsheet looks like. The spreadsheet, you can see, has 5 data points, and you'd enter the number of data points here in this cell. And then each data point is one set of these measurements, so inlet conditions, outlet conditions, mass flow rate, and power. And then in ease, you're going to do the calculations that would calculate, based on this information, the isentropic efficiency and plop it into this cell, the volumetric efficiency, put it in this cell, and the heat transfer rate, and put it in that last cell. And you want to do that for all these data. So you can do this using the macros that we've talked about, the Excel dot macro family, macro command family. And I'll go ahead and give you some time to do that. And then once you've taken a shot at it, come back and we can go through the solution process together. All right, so let's go ahead and come up with a solution to this problem. So my strategy for solving this is going to be sort of a 3-step process. Initially, I'll build an ease code that can do the calculations given a set of measurements, and then I'll work on the macro, and the macro will initially pull in one set of measurements from Excel and do the calculations, and then return the result, so the isentropic efficiency, the volumetric efficiency, and the heat transfer from the compressor. And then once that works, I'll work through the process of building a repeat until loop that can go through each of the data points and process them one at a time. So let's start with the first step, which is we need to build an ease code that can do the calculations. So I will initially set the unit system, because I always have to do that if I'm going to get any properties from ease. And then the refrigerant is always going to be what was it, R161, so I will set that in a string. And then I guess the other thing that was specified is the displacement rate for the compressor, which is 26 CFM, and I'm going to work in SI units, so I have to convert from CFM to meters cubed per second. Alright, and then I'm going to put in a set of basically dummy measurements. So these are just measurements that I can use here to get my program working. So the measurements include the inlet temperature, so let's say 7C, the inlet pressure, which was I don't know, something around 500 kilopascals, the mass flow rate, so 0.12 kilograms per second. What else do we have? We have the outlet temperature, which I think was like 55C for the first data point, the outlet pressure, which is 1125 kilopascal, and one more thing, the power. So the power is, for the first data point, 6.1 kilowatts. So I like to solve as I go, just to make sure everything looks good, and it does, I think, look good. Yeah, okay. So now we got to do the calculations. So let's see, the first thing we'll do is get the state of the refrigerant at the inlet, so I know the temperature and pressure. So assuming this is superheated, I can use that to get the entropy. So entropy of R dollar at T equals Tn and P equals Pn. And then I probably also want the specific volume. So this is volume, and I'll just copy this part here. And definitely I'm going to need the enthalpy, since I'm going to want to do an energy balance. So again, let's solve. So F2 is solve. Look at the solution. Where the solution went. There it is. And set the units for everything. What else do we have here? Kilojoules per kilogram Kelvin. And specific volume is meters cubed per kilogram. Alright, so that looks good. I guess what we should do next is maybe an energy balance. So I can get the outlet state because I know the temperature and pressure of that as well. So let's get the enthalpy, R dollar T equals T out, and P equals P out. And now that I have the enthalpy, I can do an energy balance, which says that in, which is W dot plus M dot times H in has to be equal to out, which is Q dot plus M dot times H out. And that should tell me the rate of heat transfer from the compressor, which for this test point was what, 114 watts. And probably I need to set the units of the enthalpy here as well. Alright, so that's one of the things I have to calculate. The other two things are the efficiencies, the volumetric and the isentropic efficiency. So the isentropic efficiency is based on comparing the power to the power required by an adiabatic reversible compressor. So that would be one where entropy doesn't change. So H out S is going to be equal to the enthalpy of the refrigerant at what? P equals P out and S equals S in. So that's isentropic. And if I do an energy balance on this adiabatic isentropic compressor, I would find that the work is M dot times H out S minus H in. So let's go ahead and calculate that. Let me set my units. Kilogram, and this is 4.4 kilowatts. And sure enough, 4.4 kilowatts is less than the actual 6.1 kilowatts. So that ratio is the isentropic efficiency, W dot S over W dot. And I guess I'd like to do that in percent. So let's convert this from a fraction to a percent and set the units of that to 72%. Alright, the other thing that was asked is the volumetric efficiency. So the volumetric efficiency is just the volumetric flow rate at the inlet divided by the displacement. So eta vol is going to be equal to M dot times V in, that's the actual volumetric flow rate, divided by V dot displacement. And again, let's do that as a percentage, and hopefully that all works. And I get a volumetric efficiency of 85.0%. Alright, so that's step one. If I have a set of measurements, I can now calculate the efficiencies and the heat transfer rate. So that lets us move on to step two, which is let's go ahead and build a macro that can import these measurements from the Excel spreadsheet, and then after doing the calculations, export the results back to that Excel spreadsheet. Alright, so let's reduce the size of this window a little bit, and I'll hit the macro button here and get the macro window up and start going through the process of building the macro. So the first thing I got to do is use the file open command. So excel.file open, and I'll open up the file that contains the data. So this is that spreadsheet. You have to give it the path to that spreadsheet. So I think this is C:, and I'm putting this in a folder called exercise 3, and I called it compressor underscore data dot XLSX. And if you want to actually see it, you have to use excel.show. If you don't use excel.show, it can be a little confusing because you don't actually know if Excel opened or not. Alright, so let's go maybe actually just run this part of it, see if it can start up the Excel spreadsheet, and here it is. So I can look at this now, which is helpful because I think what I need to do is figure out where these data points live in the Excel spreadsheet. So I can see here that the first data point anyway lives between C6 and H6. So I want to use an Excel.copy to copy all of these numbers. So these are the data to the clipboard, and then what I'll do is import from the clipboard and put these into the correct variables, if that makes sense. So first thing I got to do here is an Excel.copy, and Excel.copy requires the range, and so for this particular case, when I'm just doing one data point, the range would be C6 colon H6. You notice the range is a string. That becomes important here when we start to manipulate this string to try to get all of the data points one at a time. But for now, it's just that string. And I will then do an import from the clipboard. Right. So if you weren't aware of how this works, you could go look in. Let's look here under Files. Under Macros, macro command information. And we'll go down here to import somewhere right here, and if I do macro command info, you'll see it tells you how to use this, and it also tells you that the file name can be the clipboard, in which case you're going to bring stuff in from the clipboard. So that's what I want to do here, and I want to put this information into 1, 2, 3, 4, 5, 6 variables. So I'm going to comment those out, because I'm going to now set their value right here, and it'll be tn, pn, tout, pout, m dot, and w dot. Let's make sure we got the order right. So tn, pn, tout, pout, m dot, and w dot. Yep, so that's right. So when I run this now, and I'll put a solve here so I can solve, what I hope will happen is I'll import that data and we will process it. So let's run the macro, and sure enough, it imported that data, and you can see that in the macro variables window here. This is the macro variables that it imported, and then after doing the calculations, it found these values. So now all I got to do is put those values back into the spreadsheet. So let's go ahead and do that. And the way that you do that is with the Excel.cell command. So that's going to go ahead and set the value of a cell in the Excel variable to the value of an ease variable. And I have to do that, of course, 3 times, because I have 3 of these things I want to get back into Excel. So Excel.cell, and let's see. The first one is isentropic efficiency, and I guess that is I6. So we'll do that here. I6, again, it's a string, and what I want to put in I6 is eta isentropic. And then Excel.cell, the next one is, oops, why can't I get there? Here it is, J6, and that's going to be the volumetric efficiency. Yeah. So J6, eta volumetric, and then the last one is Excel.cell, IJ would be K6, and that's going to be Q dot. And if I run this now, hopefully, you should see it do the calculations and then put the results back over here. So that's step 2, right? I can process 1 data point. Step 3 now is I have to modify this macro to process all 5 of these data points. So doing this then is more an exercise in string manipulations than anything else. So let's go ahead and go through that. So the first thing I need to do, if I go back to the spreadsheet, is pull in this number here. So this is D3. That's going to tell me how many data points there are. So let's go back to here, and we'll go up here and do Excel.copy, and the range is D3 to D3. You got to give it a range, and that's going to put it onto the clipboard, and then we'll import from the clipboard that number, which is the number of data points. So now I know how many things to do in my repeat until loop. So let's see. If I look at where these data points live, the first one is in 6, and then I have to do 6 plus 1, 6 plus 2, 6 plus 3, 6 plus 4, 6 plus 5. So I'll set up a repeat until loop that does that. So let's start with I equal 5, and then we will repeat until I is equal to, what would it be, n plus 5. Right? And each time I do this, I want to do I equals I plus 1. So the first one's going to be 6, and then so on. So this range then that I'm going to use for my Excel copy, maybe let's get rid of this, or at least comment it out, is not going to be fixed. It's going to be adjusted every time I increment my counter, right? So what I have to do then is set a, let's say, range dollar, a string that contains that range, and I got to concatenate some things. So I could use the concat dollar command, but easier is just to use 2 vertical lines. That's going to concatenate as well. So let's see. It's going to be C, so that never changes, concatenated with, so 2 vertical lines concatenates that with I, basically. But I can't be the number I, it's got to be string I, so I'll do string dollar I. And then let's concatenate that with H, so the string H, sorry. And then the same thing, string dollar I. So that's the range that I want to pull in from Excel. So we'll do the same thing we did before. We'll do an excel.copy, except for this time I will use my string here, range dollar, like that. And that should bring in the same pieces of information I got before. It's just that it's line by line. So this is the data point. All right, then I want to solve just as I did before. So we'll copy this and put it here. And now I got to put back that information into I, not 6 necessarily, but I, I, right? So the way to do that is, again, set up a string. So let's do range dollar equals, and it will be I concatenated with string dollar I. Right? And then I'll just do exactly what I did before, so right here, but using range dollar. So this will be range dollar. And then let's do the same thing for the other two. So hopefully you can see the pattern. Right, this is going to be not I, but J, and this will be the volumetric efficiency. And this is not going to be I, instead it's going to be K. And that's where I will put Q dot. Hopefully I got that right. Yeah, volumetric efficiency in Q dot. All right, let's get rid of this extra white space. And hopefully now, instead of doing just one data point, it will do all the data points. So let's run it and see how that works. I don't know. Go back here. Uh-oh. Something didn't work. Illegal range C6. Oh, I forgot a colon. All of these things have to have a colon in them. So this first one in particular. So right here, we have to put a colon before that. I think the other ones are probably okay. So let's go ahead and run this. See if it works. Yep, there's 1, there's 2, there's 3, 4, and 5. So yeah, hopefully that demonstrates how you can use ease to operate on Excel data, and then put that data, the reduced data, back into Excel when you're done doing that.